In this problem number 6, for the bar shown in the figure, calculate the reaction produced by the lower support and the bar. Take E equal to 200 gigapascal, we can, or Newton per meter square, we can call as gigapascal. Also find the stresses in the each bar, right? So the given data are E equal to 200 giga Newton per meter square, or we can call as gigapascal, right? And the area of the bar A1 equal to the given data as 110 meter square mm square. A2 will be 220 mm square. So on the L1, this is L1 bar 1.2 meter, L2 will be 2.4 meter, and the deflection of L overall due to the this 55 kg Newton, the deflection of the entire bar will be, the both bar is delta L, right? Delta L will be 1.2 mm, right? So we need to find out, to find the unknown parameters R1 and R2. That means R1 reaction at the upper support, R2 will be reaction at the lower support. So we need to find out reaction R1 and R2. Similarly, stress in the bar 1, stress in the sigma 1, stress bar 1, stresses in bar 2. That is, we need to find out. So we have a solution. So from the picture we can find out that the total R1 plus R2 will be, this is the reactive force due to the applied load, which is 55 kilonewton. We can also change this as into 55,000 Newton, right? So let us take the bar. Let's take the bar 1 and bar 2. For bar 1, the total force will be reaction produced, will take as this reaction produced R1, right, is equal to the tensile load. If you take the bar 1 alone, this is influence of this 55 kilonewton as well as the R1. With respect to the second, you have to minus the remaining R2. Right? This point is common for this and this. So we don't know what is R2. So R1 will be 55,000 minus R2. Right? Similarly for bar 2, total force will be R2, that we have to calculate. It should be in compression. This is tension, this is compression, compressive one. So the only thing is, because of this applied load, this bar 1 will get some deflection L1. This will produce deflection of L2. We need to identify that. We know the formula for the deflection of bar 1. So bar 1 will take it as total bar will be deflection of L1. Deflection of L1 equal to P1 L1 by A1. Metal is common E. So we need to write for this for the bar 1. Right? So what is the P value if we identify reaction forces? R1 minus, that is R1 we have the value, or we need to apply the R1, this is R1. So R1 we have the value. So we can change, we can directly apply this value. 55,000 minus R2. What is L1? We know. What is the total the L changes in the material is 1.2 mm. So we need to put this as 1 point length of the bar as we have the length of the bar. This is L1. This is L2. L1 we have L1 equal to 1.2. So area we know. This is area. Area will be 110. That is it is having in mm. So we need to convert it as into meter. So mm square will have the 10 to the power minus 3 into square, that will get 10 to the power 6 into Young's modulus. We have 202 gigapascal, that we need to find out giga 10 to the power 9, right? So we have to calculate the unknown parameters is these two things we don't know. So let us keep this as in this form. Then we'll go for the bar 2. Bar 2, same delta L2 will be P2 L2 divided by A to E. We know the P2 value is the R2 from the value, we don't know value, and L2 we have from the given data. L2 we have the 2.4 meter. So let us substitute 2.4 divided by, what is the A2? It is 202 10 to the power of minus 6 into 202 gigapascal 10 to the power of 9 will get. So we need to, so we have the values delta L1, delta L2. So we know only we know the values of compatibility equation. So compatibility equation, we know only the changes due to the change in length in bar 1 minus change in bar L2 will produce. This is only because of this L1 load and L2 load we are getting 1.2 mm. So we'll say this as 1.2 mm. Let us change this as in meter. So it is equal to 0.0012 meter. So we know this term and this term, and we have the value, and we'll find out the unknown parameter. So let us equate these two values, delta L1, delta L2. We have this one, delta 55,000 minus R2 into 1.2 divided by 110 10 to the power of minus 6 into 202 10 to the power of 9 is minus 2 into 2.4 divided by 220 10 to the power of minus 6 into 200 10 to the power of minus 9, which is equal to 0.0012 meter, right? So here we have to have two common unknown parameters R2. So remaining terms you will get cancelled. So we'll solve this and we'll get the value. So let us solve this. So if you multiply this entire term, so this will cancel by 3 will come. So here also it is cancelled by 3 will come. So we have 2 times of the cross multiplication, you will get 25500 minus the R2 into 1.2 minus of 2.4 R2, this 2 times. This we will take this test on that side into you will get 52800. You solve this, and if you solve R2 you will get R2 equal to 16500 Newton, or else we can call this as 16.5 kilonewton. You do the mathematics here and you find out the R2. Then if you substitute this equation in any one of the equation, you will get any one of the equation, you will get R1. R1 will be 55 minus, we know this value. So 55 kgs in terms of kilonewton, this is in kilonewton we apply. So we have 38.5 kilonewton for R1. So we have R1, R2 value, right? So let us find the stresses in each bar. bar 1. So this load by area. Load is reaction, area 1. We know the reaction of R1, 38.5. In terms of kilonewton, this is kilonewton. So area they given in terms of 10 to the power of minus 6. So we'll have 0.35 into 10 to the power of 6 kilonewton per meter square. Right? So stresses in bar 2 will be sigma 2 by 2 equal to R2 divided by A2. So R2 will be 1655 kilonewton divided by A2 will be 220 into 10 to the power of minus 6. So we will get 0.075 into 10 to the power of 6 kilonewton per meter square. So in this problem we identified, so the given data are this stepped bar problem, same material, Young's modulus 200 gigapascal Newton per meter square. So the given is due to the load, we need to find out the unknown parameter reaction 1 and reaction 2 and what is the stresses formed in this each bar. So given data we have A1, A2, L1, L2 and if change in length due to the applied load. We need to identify reaction 1, reaction 2, stress in the bar 1, stress in the bar 2. So from the data we know due to the applied load, the entire load of the system is the reaction produced on this is equal to the applied load. Right? The force acting in the bar 1 is, this bar 1 is tensile. Why? Because it is in reaction upward, load is downward. So the bar is stretching tensile. So we are getting 55 kilonewton minus R2. So in bar 2 it is actually compressive force. R2 is come this side, 55 kilonewton coming this side. So the bar will be compressed. So this is, we know the only thing is deflection of each bar, we can find out the PL by AE formula. So bar 1 P1 L1 by A1 E meter is common. So we got this value. Similarly for the bar 2 we identified P1 L2 P2 L2 by A2 E. So we got this value and in terms of R2. So compatibility equation, it means if by this 1.2 mm produced because of deflection 1 minus a deflection 2. Once it reaches the 1.2 meter, it is hitting this force, this surface. So we have this value and this value, and getting solving the mathematics, and we are getting R2 value. Substituting this R2 in this equation, and we will getting the R1 value. So we will substitute here R2 value, we will get the R1 value. So we find out that the R1, R2. So this reaction we done, and so next one is the stresses in the bar is sigma equal load by area. That load is due to reaction. This is load in the bar 2. So applied, we are getting the stresses in the each bar. Thank you.